Hello everyone, my name is Karthike and I come from IIDST. Welcome to this session on data visualization in Python. Data visualization is the fundamental aspect of data analysis, allowing us to identify trends, detect patterns, and effectively communicate insights. Whether you are in a business, research, or data science, visualization data enhances understanding and decision making. In this session, we'll explore Matplotlib, Seaborn, and Plotly, powerful libraries that help create insightful visualizations. By the end of this lesson, you will have a solid understanding of different types of plots and when to use them. Data generation. Before we can create visualizations, we need data. Data can be loaded from external sources like CSV or Excel files or generated using NumPy and Pandas. We need data generation because without data, we cannot analyze trends or make predictions. We use it in sales forecasting, scientific research, machine learning, business analysis, and etc. For example, a retail company collects sales data to analyze revenue trends and predict future demand, helping them manage inventory effectively. Line plot. A line plot is used to display trends over time. It is ideal for tracking changes and identifying patterns in datasets. We need it to visualize variations over a continuous period. We use it in stock market analysis, temperature monitoring, website tracking. For example, investors analyze the stock prices over months using line plots to decide when to buy or sell shares. Bar plot. A bar plot is used to compare different categories. It is useful for visualizing differences between groups. We use bar plot to compare numerical values across different groups. We use it in business revenue analysis, product sales comparison, and survey results. For example, a company compares its revenue with competitors to assess market standing and identify growth opportunities. Histogram. A histogram helps us to understand the distribution of numerical data by grouping it into bins. We need histogram to analyze how frequently value occurs in a specific range. We use it to perform exam score distributions, customer age analysis, and product demand forecasting. For example, a shopping mall examines customer age distribution for refined marketing strategies and product placement. A scatter plot. A scatter plot helps us in identifying relationships between two numerical variables. It is useful in identifying correlations and trends. For example, a healthcare researcher examines the relationships between daily calorie intake and body weight to determine obesity risks. We need scatter plot in medical research, economic forecasting, and artificial intelligence. Box plot. We need box plot in situations like schools use box plot to analyze students' test scores, identifying those needing extra support. A box plot visualizes the spread of data and identifies outliers, helping us understand variations in datasets. We need it to detect anomalies and assess distribution. Heat map. A heat map represents data in matrix form using colors to highlight patterns and relationships. It is often used to show correlations and highlight patterns in large datasets. For example, supermarkets use heat maps to track customer movement and optimize store layout for better sales. We use heat map for customer behavior tracking, website analytics, and scientific data analysis. Pie chart or pie plot. A pie chart represents proportions of different categories. It is commonly used when comparing parts of a whole. We needed to quickly understand how different parts contribute to a whole. We use it in market share analysis, budget allocation, and election results. For example, a tech company visualizes smartphone market share using a pie chart to compare with competitors. Advanced visualization. Advanced libraries such as Seaborn and Plotly provide enhanced visualizations with better styling and interactivity. We need them to create visually appealing and interactive charts. For example, policymakers use interactive Plotly visualizations to analyze global CO2 emissions and design climate policies. We often use them in business intelligence dashboards, social media analytics, and predictive modeling. To conclude, data visualization is essential for data-driven decision making. Using Matplotlib, Seaborn, Plotly, we can create meaningful visualizations that help us understand trends, compare data, and communicate insights effectively. By practicing these techniques on real-world datasets, we can enhance our ability to analyze data across industries like business, healthcare, and environment science, etc. Let's move into the practical application. I'll be using Kaggle notebooks to demonstrate these concepts. Let's start the implementation part of this session. In the first step, we are importing libraries that we'll need for this analysis. These include NumPy, which is used for numerical operations and random number generation. Pandas, which will help us with data manipulation and handling datasets. Matplotlib, PyPlot, and Seaborn are used for plotting static visualizations such as line plots, bar charts, and histograms. Plotly Express is a library for interactive plotting which will allow us to create dynamic and interactive visualizations like scatter plot. These libraries will help us visualize data in variety of ways. Executing the first cell. As we know, there is no error generated, so all the needed libraries are imported. Generating the data. We are generating a sample dataset. I have set a random seed to ensure that the results are reproducible, meaning every time we run this code, we'll get the same random numbers. The data is generated in the form of standard normal distribution, so the number will be centered around 0 with a spread of 1, that is the variance of 1. We have generated 100 data points for analysis. Now coming on to the next cell. In this cell, we we are creating a line plot to visualize the distribution of data we just created. A line plot is a great way to show trends over time or in sequences. In our case, we are simply plotting the data points against their indexes positions in the array. Notice that the plot has markers at each data point, blue circles. Markers at each data point to help visualize the individual values. A title and the labels on the x and y axis for better understanding. This helps us see how the values change as we move along the line. So we have got our line plot and we know data generation. Coming on to the next cell, we find a bar plot. So let us first generate this bar plot. We have four categories A, B, C, and D. Each with a corresponding value. A bar plot is excellent for comparing different groups or categories. In this case, we are comparing the values of four categories. The bars are green and the height of each bar represent its values. We also add a title to the plot for clarity. So we have covered bar plot also. Moving on to the next cell, which is histogram. A histogram is useful for showing the distribution of data sets by dividing it into bins and counting the number of data points that fall into each bin. In this case, we are plotting the distribution of random data that we generated earlier. The bins are set to 10, meaning data will be divided into 10 intervals. The color of the bar is purple and the transparency is set to 70 so that you can see the bar slightly. Coming on to the scatter plot. In this cell, we are creating a scatter plot which is great for visualizing the relationship between two variables. We have generated two random variables x and y and we are plotting them as points on graph. Each point represents a pair of x and y values. The scatter plot is red and it's easy to see if there's any noticeable pattern and trend between two variables. As you can see, the data is scattered all over the graph. The red dot indicates where the x and y coordinate meet. Due to this scatter plot, it is easy to see if there is any noticeable pattern or trend between two variables. Coming on to the box plot, let us run this cell first. So in this cell, we are creating a box plot to summarize the distribution of data. Box plot provides a clear visual representation of the datasets, minimum, maximum, median, and quartiles, and it also highlights any outliers in the data. So basically, outliers are the values which vary vastly from the original set of data. So during machine learning or during training a machine learning model, we usually remove these outliers, which will be covered further in the session. Coming on to the next cell, we find heat map. Let us execute the cell. You can see the plt.show function is used to show any graph that is being reduced. So you can clearly see the heat map developed in front of you. In this step, we are creating a heat map, which is a way to visualize a 2D matrix where the values are represented by different colors. This is useful for visualizing relationships or patterns in data, especially when dealing with large datasets or correlations. The not true argument adds the actual numerical values to each cell, and we are using the cool warm color map to make the plot visually appealing. Mm, There are other color map which can be used according to the need. Coming on to the next plot, we have pie plot or pie chart. We are plotting a pie chart which is used to show proportions of a whole. We have four categories with the values that represent the size of each slice of the pie. Each slice is colored coded differently for easy identification. We also display the percentage. We also display the percentage with auto PCT equals to percent 1.1 f percent, which shows the percentage with one decimal place, which can also be changed according to the need.